Hello, everyone, and welcome to another episode of the Counterpoint Podcast. I'm your host, Peter Richardson, and joining me today is a very special guest from Qualcomm to talk about on-device AI, on-device generative AI, more specifically. So please welcome Ziad Asghar, who's Senior Vice President of Product Management and Head of AI at Qualcomm. Welcome to the show, Ziad. Great to have you with us today.
Thank you for having me, Peter. Excited to talk to you.
Great. So generative AI has been one of the hottest topics in the last few years, actually. Now, we've discussed different aspects of the technology on previous podcasts, and we'll put some links in the show notes in case listeners want to find out about those. But today, though, we want to delve a little bit deeper into how to run generative AI on the types of devices that people interact with every day, as opposed to supercomputers in cloud data centers. And I guess this is really where Qualcomm has some very special capabilities, which hopefully we're going to get into in a bit. But just to kind of kick us off, can you help us by defining some of the terms that we're going to be using here today? I mean, for example, we're mainly going to be talking about generative AI, but how should we think about generative AI versus machine learning or other types of AI that people might be familiar with?
Sure. I think I'll start more with where we have been as a technology and as a technology and as an industry. It's always been about telling the computers, well, you do this, and if else then, right? It's been a very clearly defined way of interacting with the machine. What's changed is that we have this umbrella term, which is artificial intelligence, which really encompasses machine learning and deep learning and then generative AI. And essentially, the idea with artificial intelligence or AI is to be able to give machines the capability to mimic some of the human behaviors by allowing them to be able to learn and then to behave in certain facts, in certain ways, the way that humans do. And then the term beneath that, you can think of it as deep learning, where basically you are able to take large amounts of data and allow the machines to be able to learn and essentially apply those techniques and automatically do certain behaviors. And then I guess the step below that is the ability to be able to take neural networks and apply them to these use cases. And that's machine learning, where the machines are able to take vast amount of data and apply neural nets to be able to do artificial intelligence like use cases. And then generative AI is a subset of essentially those techniques where you're actually applying machine learning and deep learning techniques to generate content. You're generating text and images and video and 3D in the future, where essentially this used to be the realm of human behavior, right? Generating content and generating art. Well, now I can go and tell a machine, hey, here is a text and make me a picture that essentially depicts exactly what the text says. So that's the really amazing thing about generative AI. It can generate emails for you, it can generate code for you, it can generate things that in the past required direct human attention. Of course, there isn't a day that goes by in news and in tech media, at least, where people are talking about new techniques and new ideas on how to be able to do these generative AI use cases even better.
Okay, that's very helpful. Thanks. And of course, smartphones have been running AI workloads for quite a few years now. And for example, scene recognition in photography, for example, something like that, or maybe even optimizing the radio propagation characteristics, those sorts of things. So those use cases don't go away; they don't get replaced by generative AI, right? So they'll still be around.
Absolutely. So, I mean, we've been using rather, I'd say, artificial intelligence as a technique in multiple technologies, right? I always call AI a horizontal technology. What I mean by that is you can actually apply it in camera, in audio and speech and video and modem technology. And we've truly been leading the pack over here, where we've applied it, for example, to camera to be able to allow you to see in the darkest of rooms and yet be able to get a good picture out of it, or to apply it to improve image quality. And then, of course, we've taken it all the way down to where we're applying it to modem technology as well, to be able to get better signal in worst of conditions, in in the hardest of channel conditions as well. So all those use cases where we're applying it to audio, video, camera, and all of those previous technologies stays and continue. But now the real, I guess, excitement that comes on it, that now you actually have use cases that are directly using artificial intelligence to be able to add value, to be able to add new experiences to the products that we are so dear to us, like smartphones that we use on a very, very regular basis. So yes, all those use cases continue, which means the device, of course, needs to do even more than what it was doing in the past from an artificial intelligence perspective. And what that means, Peter, is that essentially whoever can do more AI processing with lesser power is going to come out looking great in this new revolution era.
Mm, okay. That actually kind of brings me on to the, one of the focal areas of generative AI that a lot of people have been talking about, and we see this in terms of results from companies that are creating the chips that go into the data centers for training these big large language models, and that's this kind of the scaling issue. So I think in general, the larger the model, the better its performance. Although I guess there are some counterexamples to that, and if we scale the model size, the number of parameters involved, there's maybe a kind of a consequent need to increase the scale of the computing resources used to train those models, and maybe also by implication, maybe you can disabuse me of this notion, perhaps the resources required to interact with those models to do the to get some output from them. And you look at some of the powers that are being, the compute power that's being used to train these models, and it's kind of staggering, right? So even top 10 supercomputers from a couple of years ago are not up to the task of training these models. So how should we think about this scaling issue? Are we sort of on a trend where the models just get larger and larger and larger, or are we sort of reaching a point where actually we're now kind of beginning to look at different options and different ways of doing this?
Yeah, I think it's a very interesting question. So, I mean, one of the things, like you pointed out, we are seeing that models are getting bigger, but I think they get bigger, and then, at least the way I look at it, they start to become somewhat smaller. So let's take the example, for example, of a text-to-image model like Dolly, right? Dolly started, I think it was about 10 billion parameters, and then now what's being utilized extensively is Stable Diffusion, that's about a billion parameter, and it still does an amazing job of those text-to-image like use cases. So one thing that is happening is that when you add a new modality, at that point in time, the model is pretty large. But then with all the whole tech community working on these technologies, what is happening is that the algorithms and the way the models are constructed, and the way that the data is curated to be able to create that model, all of those things are getting better. And so with time, those models start to actually become smaller in size. I think if we take another example for text to text, Chat GPT 3, it was about 175 billion parameter model. But if you look at Llama and Llama 2 like models from Meta, they are in the 713 billion parameter range. And in some of the metrics, actually, Llama does fairly well when compared to ChatGPT 3. So again, a similar trend like we talked about in the text to image case. So I think in the beginning, you can argue that it does become large, the model, but as the algorithms and as the data curation gets better, or as you make the model more, domain specific, essentially you're actually able to reduce the model size. So, and that's where I think it's a very interesting trend, and that's why it allows us to be able to do a lot of these amazing use cases on device, in the future. Yeah, and then I would like to spend a little bit of time talking on the training versus inference difference as well, right? So, of course, the model gets trained once, and these large models, like you pointed out, take a lot of energy and power to do. But honestly, inference is not that cheap either. So, if you look at it from the perspective of some of the news that come out recently, OpenAI talking about, it costs them about $700,000 a day to be running just ChatGPT 3. I think that's the other part of it. And like you were pointing out, it's a lot of computation that you have to do. But that's where I think the promise is, right? If you could do that large amount of computation on the device, which is what we have been driving as a company, and I personally have really seen, the promise that that has, and I think that really will give us and the consumers and the industry many advantages by being able to do this on the device. But the other aspect that I also want to point out, even though we will not be doing full training on the device anytime soon, but there are some interesting techniques that are coming up, like low rank adaptation and all, where you could, for example, take a model and be able to fine tune it on the device. And it's actually reasonable and it's not as computationally intensive, which can really curate and optimize the experience for a given user on the device extremely well.
Okay. And you mentioned Stable Diffusion and DALI. Um, Now, I saw the demonstration that Qualcomm had at MWC back in February, where you were running Stable Diffusion on a Snapdragon device that was, didn't have any access to the cloud. I think it was in flight mode, and it was producing pretty impressive results. And it was impressive. It was kind of neat. But what do you see as uh, the kind of day to day applications for generative AI on say on a smartphone device? What do you think will be the main ones that we'll see initially, and then how those will develop over time?
Yeah, I mean, I think Stable Diffusion and what we showed at Mobile World Congress really showed, I think, the possibility. It showed the fact that, you can do these use cases on the device. But, we are in touch with each one of our customers. There's a huge slew of amazing use cases that they want to bring on the device, which we believe we'll be able to do just, this year and, early next year as well. You'll see a lot of those come. But from a smartphone perspective, right, it's a very interesting device because, again, this is where the data is being generated to a great extent, right? If you're talking about, for example, image, this is where your camera is sitting and you're doing the camera, you're capturing that image on the device essentially. So for example, one great use case that people are looking at is, we could take this picture exactly like, we have you with your background, Peter, and you could just tell the device to put you in front of a very different background. And it can just essentially generate that background using Stable Diffusion or control net like models, which we can actually, by the way, run today. Because since Mobile World Congress, we've actually shown control net running entirely on the device as well. And that's, by the way, 100 and it's a 1.5 billion parameter model. So even larger than what Stable Diffusion was. And you can essentially do that on the device, and it's a great use case whether you are whether you are a young person using the device or somebody else. But the one that really is very exciting to me is a true virtual assistant like use case, right? We've talked about it for the longest time, but now you can just envision, right? I can say something into my device. We use a model like Whisper to be able to change that to text. And then that text can be going into a Llama 2 like model where you essentially run the query and you're able to actually generate an answer that's back in text domain. And then you apply that to a text to speech where you essentially are able to generate speech from that text. And you could then even put that into what we call like a face model, where a person is able to move the lips and everything on your screen, say exactly what was basically asked about. So essentially what you have created is a pretty complete end-to-end virtual assistant model. And now you can envision the possibilities, right? If it changes the way that we interact with a smartphone, if it changes the way that we use all the different apps underneath in a day-to-day basis, right? Like today, right? I always give this example that, let's say you're setting up a reservation at a restaurant. You can go to an application to be able to find the ratings of restaurants. Then you'll basically go to that restaurant's app perhaps to basically schedule that reservation. And then you'll actually figure out and go to the navigation app to figure out how do you get there. Well, your virtual assistant could tap into all of those underlying apps and essentially do all of those things for you. And I think that's where it becomes really interesting as to how we interact with them. Of course, for people like us who use the device for a lot of work, you can do, for example, a document summarization, or you can do, for example, you can have a draft of an email generated by the phone for you, and they can just review it and edit and modify it and send it out quickly. You can have it basically. You take a video conference call with your phone, and you can generate the transcript for it, for example. So really, I think the use cases are many, and as we interact with our customer partners, they're coming up with new ideas that we are working with them to be able to launch on the upcoming products.
All right, and I mean we've been talking here a little bit in a sort of an either or sense or a binary sense, either in the cloud or on the device. But I think what if I listen to what you're saying, we're more likely to end up with some sort of hybrid model, right? So where some of the some of the workload is done on the device, maybe some of the inferencing, maybe some of the the learning is done on the device. So to use your kind of personal assistant example, you want the I use the sort of term AI in a very kind of general sense here. You want the AI to kind of learn about your habits and things that you like, or preferences and so on. But you may then require it to to interact with other networks. So you need some sort of cloud interaction at that point. So I guess we're really talking about this sort of hybrid model, right?
Yeah. It's a good point. So essentially, the way we are envisioning how AI works in the long run is basically what we're calling hybrid AI. What that means is that as our devices become a lot more capable, which we are driving right now, you'll automatically be able to do a lot of this processing on the device. But additionally, what you can also do is that, let's say, a model size above a certain level, you can essentially say, I'm going to run this in the cloud, for example. Or you can also have a certain degree of interaction between the cloud and the edge to be able to still continue to offload the cloud even further. For example, you can do some of the token processing on the device and then the remaining in the cloud, and be able to offload it by having perhaps a smaller version of the model run on the device and a larger version in the cloud. So there are many techniques that we are looking at. We're working with our partners to really be able to bring this hybrid AI vision to fruition. But a big component of that is, of course, how much we can do on device. And there are many myriad of benefits of really doing that as well. Because just imagine, right? I mean, when you do some of this processing in the cloud, it's running on large graphics engines that are burning hundreds of watts of power. And then you were there at Mobile World Congress and you saw we were running this use case on a handheld device, and our team basically showed it the whole day. And essentially, it was we never even plugged the phone in the whole day. So we do it in milliwatts of power compared to hundreds of watts of power. And I think that really changes the way you are able to bring generative AI to the masses.
Yeah, and I think it's a very very kind of interesting, but also an important point from a sustainability point of view, because I think one of the criticisms or concerns about these huge large language models is the amount of power that they consume when they're uh, yeah being trained, but also the inferencing part as well. I wanted to touch on a bit more about the well, two aspects really. One is hardware, one is software. So Qualcomm is perhaps best known for the Snapdragon line of uh, application processors. So how is Qualcomm leveraging its capabilities on these silicon chips to really kind of unlock generative AI here? I mean, you have different compute elements within the chip. So are they used, individually, or are you using, some combination of, the NPU, the CPU, GPU? How should we think about that?
Yeah, we think really about AI in the hybrid sense, even on the device, or heterogeneous sense, I should say. And the way that we have set it up is we have multiple engines on the product to be able to do AI processing. Like you pointed out, CPU is an engine that can do AI processing. So can the GPU, and then so can the NPU or hexagon processor that we have on our product. And then I'm responsible for driving the one technology roadmap at Qualcomm. So essentially, we create these core technologies like the hexagon processor. It's really designed in a way that it essentially maps to the architecture of a neural network. You have scalar components, you have vector components, and then you have the matrix components within the hexagon processor. So if you look at it from the perspective of power consumption, for any sustained use case, hexagon processor is going to be able to do that AI workload at far lower power than CPU and GPU. But the ease of use in some cases as to how familiar the developers are to the CPU programming model versus the GPU programming model allows a lot more developers to be able to start to use our silicon fairly quickly by leveraging CPU and GPU as engines. We, of course, have very good runtimes like Snapdragon Neural Processing SDK and even TensorFlow Lite and other well known frameworks in the industry to be able to use Hexagon processor as well. But just a number of people who are familiar with how to leverage those capabilities on a CPU and GPU is larger. And I think that's why those engines are also extremely important. And so the way we are thinking about this, Peter, really is depending on the use case, there might be smaller networks that are actually quite fine to be able to run on the CPU. or those networks that might have spotty performance, right? You run it for a little bit, then it goes away. But I think when we talk about sustained use cases, which is use cases like text to text and others, you would have to be able to run it on a specialized engine like the Hexagon processor, really to be able to get the right power consumption in a device that's not plugged in. And that's why we have set it up this way, such that we're giving our customers and partners and developers all the flexibility to be able to use the right engine. So our Hexagon AI Engine Direct, you talked about the software, is set up to be able to leverage the CPU, the GPU, and the Hexagon processor equally. And we've spent quite a lot of time creating our Qualcomm AI stack. And the way we have created it is such that it's actually common across all of our product lines, whether smartphone or AR, VR, or PCs, or automotive or IoT. And essentially, what you can do is, and the power that it gives our customers is that you can really just build it once and deploy anywhere. So you build a great model, let's say for text to text generation. Well, you can create it for the smartphone and then take it and run it in the automotive context or run it on IoT. And I think that power that comes with Qualcomm scale is just amazing, right? Because at any given point in time, Qualcomm has more than a billion devices that are deployed. We bring in a few 100 million devices every year. So the scale that we can bring, with our hardware and software, we really are able to democratize these use cases in a way that no other company can, in my opinion.
Excellent. Thanks for that. And maybe that's a kind of a good segue into sort of talking about the partnerships that you have with other companies within the ecosystem and the developer community. So yeah, clearly you're kind of working with a whole host of different players. Can you talk a little bit about where you see that going, both from the sort of the large players, but also some of the smaller developers?
Yeah, so we definitely are working with pretty much every level in our ecosystem, of course. So we have we're working with Meta, for example, on bringing Llama 2 like models, which are great text to text models, and we are able to bring them into smartphones, into PCs, into automotive, any product line essentially that uses our technology. We have a pretty close relationship with Microsoft, and at Microsoft Build, we actually showed many of the capabilities for the developers also to be able to run models like Stable Diffusion on a PC. And in the PC space, Peter, it's really interesting. We are really the only vendor that has a specialized accelerator for AI processing. The other vendors do not have that capability. So, like we were discussing on the last question, they are forced to run those cases on CPU and GPU. And as you go into the realm of generative AI that's running nonstop, that's sustained use case rather than a spotty use case, you cannot get the power to be right when you're running it only on CPU and GPU. So that's another advantage that we get. So working very closely with Microsoft to bring Copilot like use cases to the Windows on Snapdragon product lines. We are working, of course, with all of our customer base very closely. We, of course, are very much engaged with Google as well on all the different vectors of how we are able to bring these use cases to the device. At the same time, with our customers, partners, we are coming up with new use cases that we are meeting with them on a regular basis, and they have these amazing ideas and want to make sure that we are able to bring them onto our upcoming products. And then from a developer perspective, like I mentioned, at Build, we have essentially shown how you can do it on PC. Similarly, we have some very good frameworks like the Snapdragon Neural Processing SDK. Or if you're a developer who's using TensorFlow Lite or PyTorch, we have ways to be able to leverage that capability and be able to use the full capabilities of on the device and allow the developers to be able to get all of that benefit in real use cases.
Okay. I wanted to, I'm just conscious of time here. We don't want to kind of run you into your next meeting. But something that we've not really kind of touched on yet is privacy and security. Whether we're running these generative AI models, whether it's on the device or in the cloud. And I guess one of the attractions of doing this on a device is you can confine the data to some secure area on the device itself and not send sensitive data up to the cloud where you may have less control over it. How should we think about that? And does Qualcomm have a particular perspective on on this topic.
Yeah, I mean, this is exactly why you're seeing on-device generative AI getting so much traction. I mean, exactly what you said there, Peter, right? If, let's say, you put in a query, and let's say as time goes by, we are more reliant on these generative AI like clients that are running on your device. And let's say you're putting in personal information in there. You really don't want that going to the cloud. And in past days, we've seen news about people putting in code snippets into some of these generative AI like tools to be able to create and generate code, and you can imagine that some of that code can be proprietary. So the real promise with generative AI, and why I strongly believe that the center of gravity for generative AI processing is really shifting from cloud to the device more and more every day, is because of some of this privacy concern. But there are actually a lot more additional benefits of why you want to do this on the device, right? So we talked about a little bit of the power benefits in the past, where like we said, large engines running hundreds of watts of power. But think about what's happening, right? What is happening now is the model sizes, like we talked about, which used to be hundreds of millions of parameters. Now they're billions of parameters. So the model size has increased by 10 to 100, if not more. Second factor that's coming in is that there's a lot more use cases using these generative AI capabilities. You got text, you got video in the future. What I see is from a trend perspective, you'll have multi-model AI coming up. So you'll have not just text to text, but you'll have text to video, or you'll have image to video, or you'll have image to image, or you'll have, so the capabilities will become multi-model rather than just a single modality in what we do. So a lot more use cases are coming up. Then a lot more people are excited about generative AI use cases, so they are coming in and using these capabilities. So when you look through these three factors that are really multiplicative in nature, you really cannot scale the cloud capability to be able to run all of this in the cloud. And that's why generative AI needs on device to be able to reach its full potential. That's the only way to do it. And that's why, we're super excited about it, because we can actually do these use cases. We can do, Cristiano has mentioned we can do more than 10 billion parameters this year on the device. So the capability that we have is really massive. So that's like the second major benefit of being able to do it on the device. So, and like we talked about power is basically a proxy for cost. And essentially, you are going to be burning quite a lot of cost. And, I talk to customers and they tell me, look, I want to do this use case and I have it running in the cloud, but I'm limiting it. I'm not letting people do as many queries as they want because, well, every query is costing me money. Well, if you do it on the device, it doesn't cost money, right? So it's really very powerful. But the most compelling benefit that I see is even more than that, which is really an optimized and curated experience for each and every person. What do I mean by that? Your device has your contextual information available on the device. It knows kind of your likes and dislikes. It knows kind of your age. It knows your queries from the past. We plan to use that contextual information to be able to do exactly the techniques that we talked about earlier, like LoRa, which is low rank adaptation, and others, to be able to fine tune the model for each and every user. But you know what that means? It means that you will have generative AI experience that is far better on device than it can ever be on the cloud. Because you don't want to send that information up to the cloud again. It's very private information to each and every user. So the benefits of on-device AI are just manifold, and I think it really allows us to be able to put generative AI use cases in the hands of each and every person that has a smartphone, that has a PC, that has an automotive device, right? It's just as amazingly powerful in that sense.
And I wanted to sort of touch on some of the the variety of edge devices. So you mentioned there smartphone, PC, auto. Yeah, there are some others maybe, but if you are creating tailoring a model for one user, how portable will that be across different domains? So my smartphone is the thing that I sort of carry with me all the time, but when I launch my PC, am I going to be having the same experience there as on my smartphone? Or if I jump in the car, am I going to have the same experience? How transportable is this capability?
Yeah, just like I mentioned earlier with our Qualcomm AI stack, we basically have this ability to really build once and deploy anywhere. So as you are taking it from one Snapdragon product to another Snapdragon product, you will have the ability to be able to take that model from handset domain to the PC domain. And what we are creating is this ability for devices to really work together much more seamlessly. And you can literally take a model, say, from the other side too. You can take an IoT model and bring that to smartphone side also. But like you point out, right, that model that's specialized for you, that model that's specialized for me, I can actually take that from smartphone, and you get a new device on your PC, and you take that model that's already ready to go, and you basically give access to that, and the new device is able to actually use that model that's best for you. So you know what happens with time? That model on the device becomes more and more specialized to each user, whereas the model in the cloud is more and more distant from it. And that I think is the true promise of on-device AI.
Okay. Well, beginning to wrap this up now, Ziad. So, yeah, maybe thinking about the next, I don't know, 5 years. Let's say what are the you've talked quite a bit about some of the use cases that obviously you're excited about, but are there, two or three that really kind of, you can't wait to see emerge?
Yeah, I think I really like the fact that the technology that we create provides human benefit. It provides social benefits, right? So one of the things that we've been looking at is how we can apply generative AI to healthcare, or how you can apply generative AI to education domains. How you can apply generative AI to, for example, elderly care. So one of the what I am quite excited about is, like, if you look into the future, if, for example, take the example of a classroom, and you are able to understand how well each and every student in the classroom is really able to digest the material that's being given to them. And that could be by virtue of a camera or something that sits in the classroom. You take in that information, and with generative AI you are on the fly able to change that lesson plan based on exactly how well each and every student is getting the material. This is the power of it, right? They have a tablet in their hands. That tablet is looking at it, and they can see that the student is somewhat, not getting the material. You slow down the pace of delivery. It's a optimized education delivery plan for each and every student. You can never have that happen, right? So generative AI really opens up these amazing, capabilities in the education domain. Now, and similarly in healthcare, if you have an elderly patient, you can have a device in their home that again gets all the information from the sensors that they might have on their device, the blood pressure information, the heart rate information, the temperature information. At the same time, it's able to converse with the patient, and essentially see if they might be incapacitated in any way. They don't have to wait to go for the next appointment before which the therapy can be adjusted. You can actually do it on the fly, of course, working with a healthcare provider. So you can actually do that. I mean, in automotive domain, you can have the experiences of a night rider like experience, right? I mean, essentially, you can be talking to your car. You can be having that amazing experience of it being a true assistant to you. Right, you're coming into work and you tell it, well, I got these 5 things I gotta solve today. So can you please schedule these meetings? Let's get those people to send out this information by this time today. Right, all of that gets done. Your commute becomes a productive time for you, right? And then, of course, if you look further out in time, there are even more exciting use cases. You can think of, one of the domains that we have, which is AR, VR, really lends itself extremely well to generative AI, because you're creating this virtual world with virtual objects around you. And you can actually take that information and cues from what the person likes and generate all of that. But what if we could have an avatar of you that actually goes and represents you in meetings that you are not able to go, and it actually sits in a Teams call or in a Zoom meeting, and is able to converse and say exactly what you are going to say, because it's trained on your data, and essentially is able to represent you, and then come back after the meeting and say, well, these were the questions I could not answer, so please make sure you send out an email addressing those ones, and gives you a running commentary of what happened in the meeting. I mean, the possibilities are endless, and so really, we think we're really scratching the surface at this point in time with generative AI. There's just a lot more to come, and I think what we can do on the device, with the curation, with the optimization for each and every user, is really going to evolve the way we entertain ourselves, the way we work, and just really change the productivity of each and every person. I mean, I also say that it's really a very good force multiplier, is the way I think about generative AI, because it will take away the mundane, it will take away the routine work from you, and really free up humans to be able to do what they do amazingly well, which is essentially novel ideas, innovative work. So I think that's where I see generative AI really taking us in the future.
Well, I think that's a fantastic place on which to end this. And Thanks, Ziad. It's an excellent and very insightful discussion. So glad you could join the show today and share your knowledge with us and with the audience. And yeah, thank you very much.
Thank you for having me. It was great talking to you.
Thanks, and for our listeners, thanks for tuning in. As always, you can head over to Counterpoint Research or your favorite podcasting platforms to listen to this and previous episodes. And if you'd like to know more about on-device generative AI and talk to our analysts, please do drop us an email at press@counterpointresearch.com. And with that, thanks very much. See you on the next one. Bye now.